Alright, we're going to do problem 5. Find the area enclosed by y equals sine 2x and y equals x squared minus 4x plus 1. This function is going to look something like that. This function is a parabola, open and upward. We're going to need to see what this looks like. We need intersections to get an idea of where our graph is, where the enclosed area is going to be. But to solve this for x, that's kind of a problem. Oops, move this over. So what I'm going to do is, I'm going to do this on the calculator, and we'll be able to see what our intersection points are. If I go into the graphing screen, I've put in sine 2x as my first function, x squared minus 4x plus 1 as my second function, and then let's graph those. I'm going to do zoom trig because then I like how the sine function sits at those exact points right there. And then, okay, there's my parabola. So I can see the first intersection point's not quite at the origin, second one's over here. So let's actually calculate those intersection points. Second calc, intersect. It's automatically going to select your curves for you. There's y1, there's y2. Guess, the cursor is right there, so we'll just use that as our guess. There's my first intersection point, x equals 0.17278, and so forth. What I'm going to do is I'm going to store this as letter A. That way I don't have to round in the middle of the problem, because you definitely don't want to do that. So I'm just going to quit this, and I'm going to say x store alpha A, and it will repeat the value that you had. I'm going to go back to my graph and calculate the second intersection. So calc intersect. First curve and second curve, still you can select the same way. For the guess, I need to move over closer to the second intersection. I'm just going to the right until I get closer to that one. And it has found my second intersection at 3.9975 and some change. I'm going to let that equal b. So I'm second quit, x store alpha b, and there's the value. So I'm going to use those in my integral instead of using rounded numbers. You always want to do that. It's good practice. And you don't need to round in the middle of the problem. Alright, I'm going to go back to my graph so I can sketch this out. Just a little bit right of the origin. There's my sine function looking somewhat like this. Here's my parabola looking something like this. And I need the area between these two curves right here. Now if you notice, this is my sine 2x function. Between these points of intersection, that is always the top function. And that's going to be important when we do the integral of top minus bottom. You need to make sure that there's not a change in what's the top function and what's the bottom function. My parabola here, y equals x squared minus 4x plus 1. That's always the bottom function here. You know, if our boundary was going to go beyond this, notice how right there it flips where the top function is now the parabola, the bottom function is sine of 2x. We'll have problems like that in the future where we have to deal with that, but for now, since we're just looking at the intersection of these two, this is all we need to deal with. So our integral is going to be from here to here, and let's label that. This is A, and that's point B. Another advantage of assigning these values like this, you just label your graph with that. So we're going from A to B of the top function, which is sine 2x, minus the bottom function, x squared minus 4x plus 1. Don't forget these parentheses, because you definitely have to treat that negative sign properly. Okay? One, I want to reiterate again, this is just like summing up a bunch of rectangles, where this is the height and this is the width, right? Now this I'm just going to do on my calculator. using these a and b values too. So I'm going to go to Math 9. The lower boundary is a, upper boundary b, so just use alpha a, alpha b. Top function, sine 2x, minus, open parentheses, the bottom function, x squared minus 4x plus 1, and then this is dx, and I should be able to get my answer. That does not look right. Oh, look what I did wrong. I forgot to close the sine 2x, so second entry, let's do this over again. I'm just going to go right there and insert a right-hand parenthesis. And I think I have one extra. I'm going to delete that one. Try this again. That's the correct answer. 7.325. Okay, tomorrow we'll start with problem number 6. Have a good day.